All right, we were going over the area under the curve. And by the way, curve just means any graph. In fact, in this case, the curve that we're talking about is the straight orange one right over here. So the area of the curve, we were determining that area. We're a little rushed, but the easiest way is to think of this as a rectangle down here and a triangle up here. The rectangle has a base and a height. And since the question is asking you to determine the area, you must know both the base and the height of the rectangle. The base of the rectangle runs from left to right from 0.0 to 4.0 seconds. So that gave us our base of the rectangle. The height of the rectangle runs from 0.0 up to, now I arbitrarily made this dashed line so that I could break this into a rectangle and a triangle. So my dashed line comes through right about 7.5 meters per second. So my height then of this rectangle is 7.5 meters per second. Here it is. And then when it comes time to determine the area of the rectangle, base times height, I plug in the base of 4 seconds, the height of 7.5 meters per second, and multiplying those two, 4.0 times 7.5 is 30. And seconds times meter per second just results in meters. In case you had an issue with that, seconds times meter per second, you can put this over 1. Multiply across, not across multiply. If equals were in the middle, it'd be across multiply. Seconds times meters over seconds. Seconds cancel. We were left only with meters on our unit over here. We also need the area of the triangle because it asks for the entire area. So the triangle base runs across left to right the entire width of the graph here. The area was for the first 4.0 seconds, so it runs the full length of, actually our graph ended at 4.0, so it's convenient. So the base here is 4.0 seconds for the triangle. Here it is. And the height of the triangle is actually from this location up to this location. Now that's not the easiest. You have to do a little subtraction. This location starts out actually where our rectangle ended, so it's 7.5 meters per second. It goes up to, my graph I'm going to estimate is 15.8 meters per second. Your graph may be a bit different. Heck, if yours is 16, your life is easier. But to get that height, you must subtract the 15.8 minus the 7.5. So 15.8 minus 7.5 will leave you with 8.3. There's the height of the triangle, 8.3 meters per second. So now we need to find the area of the triangle. Here's the equation. Area of the triangle is 1/2 base times height. So over here, area of the triangle is 1/2, 4.0 seconds times 8.3 meters per second. And so the area of the triangle will come out to, half of 4 is 2. 2 times 8.3 is 16.6. And seconds times meters over seconds results in meters again, naturally. So our final answer for the total area of this strange trapezoid shape is the sum of the two, 46.6 meters. And if we're going to go just to the nearest one, that's 47 meters. Now, this area actually has some significance. This is the one part we missed during class. We're going to fill it in right now. Why would I have you calculate the area? What does that 47 indicate? Well, it actually does indicate something. We go back over to page 26. Down at the bottom, we have to calculate the area. And we found that the area of the trapezoid was, and this is for this graph, this area under here, was approximately 47 meters. Your area might be slightly different. But then we get to this next question, which is, what does the area represent? This is actually a great question. So if we look back at our graph, speed was the y-axis, time was the x-axis. Here was the graph. The area is underneath there. What does that area represent? Naturally, area represents is looking for words. Now, to back up, let's use the slope as an analogous scenario. Slope, to calculate slope, you did delta y over delta x, and you plugged magnitudes in here, or numbers with units. To find what the slope represents, you still did delta y over delta x, except you put the axis titles in here. You put words in here. The same holds when dealing with area. Area, to calculate area, you're roughly doing base times height. So if you're going to do the area represents, you will do, again, base times height. Sorry, base times height. Here, you put a magnitude and a magnitude. Here, you are actually putting, just like before, an axis title and an axis title. Those will be the words. Now, it's not that tricky. Base is the horizontal axis, aka the x. That should be an x. Height is the vertical, aka the y-axis. So in fact, come up here to your little definition, your vocab bar. Area represents, roughly speaking, is what you see right down here. It's going to be x-axis times the y-axis. That's it. Now, there's a slightly more technical version of it, which truthfully won't bother most of you, but the slightly more technical version is, and you should write this down as well, it's really the change in the x-axis label times the average y-axis label. Now, why that is, we'll get into a little more later. Truthfully, why that is because we don't have a calculus course here. So this is like the level below calculus version of doing area. Doing area underneath the curve is actually a calculus question. But anyway, we'll do the simpler version here. By the way, you'll call this an integral when you go to calculus. Okay, so that's really the technical way. So if we're going to look here, go back to question 71. You're going to look here. Table 1, that's the straight, and table 2 is the curve. Table 1 is going to be, just as we saw, area, base times height, will represent, well, what is the base? The base is the time. So we have the technical version, this one, the change in the time, I'm going to write it in words, times the height, which is the speed, and technically it's the average speed. Table 2 also comes from the same set of axes. So it's going to be the exact same thing, except we're a little better at this now. So why don't we actually try to write this in symbols? So here in symbols, we learned in the previous problem up here, change in time is captured in our reference table by the letter T. Average speed, if you actually look, average speed is in your reference table on page 6. Average speed has a symbol. Maybe I'll pull that reference table over for you so you can see it. Well, go ahead and have a look at it as we're talking. Physics reference table. So average speed, let's bring this over here. Page 6. There it is. Average speed actually is what we call V bar. It's V with that little line on top. So here, we have a multiplication by V bar. Okay? Now, as we saw before, does this equal anything? And the answer is yes. This is T multiplied V bar. Where do you look? PRT 6, Physics Reference Table, page 6. If you look on Physics Reference Table, page 6, there's no equation that literally says TV, but there's one that you can rearrange to say TV quite readily. And it is the very first one on the mechanics page. It says V bar equals D over T. And so let's come over here and borrow this for a second. On PRT 6, it says V bar equals D over T. Could we rearrange this equation to look like T times V? The answer is yes. How? Cross multiply. The equals is in the middle. This is V bar times T equals D times 1. V bar times T, T times V bar. It's the same thing. What does that equal? D. And this is actually the coolest part of all. On your reference table, where is this dandy? D is displacement or distance. Let's think of it as distance for right now. D is distance. So wait a minute. We figured out here that on a speed versus time graph, the area represents distance. That means if we were to calculate the area, then the result should be a measure of distance. One more time, because the axes here are speed versus time, area represents speed multiplied time, v times t, which is d, distance. So that's saying that this area underneath, the yellow and the green together, should equal the distance that the object traveled. And as it turns out, we found that area to be 47 meters, a distance. This is very cool, because what this means is by just having that lousy video of the dashboard and getting 4 data points, not only of speed versus time, not only were we able to determine the acceleration by doing the slope, we were actually able to determine how far the car went in those 4 seconds just by calculating the area. That's pretty powerful. No cones, no tape measures, no picture of the outside of the car. All we need is the speed versus time data, and we were able to calculate the distance the car traveled. That's pretty neat. That's primarily what you have to do with your graphs right here. That's a heavy duty. One thing over here to fill in your margin, just so you have it. Over here on the right, area beneath the curve, of course, is shade underneath the line down to the x-axis. We will actually shade, sometimes over a graph that goes under the axis, we'll shade up to the x-axis in that case. Break it into right triangles and rectangles. By the way, they don't have to be right triangles. I'll put that in parentheses. It could be any triangle, but right triangles are a little easier than average to work with. Determine the area of each segment in sum, just like we did, the rectangle and the triangle. Use the scale, no counting boxes. And finally, include your units. So this whole deal is in there now. I'm sorry I told you this was going to be 3 minutes. Clearly, that was a little ambitious on my part. However, hopefully this rounds out our knowledge of interpreting graphs right here. And you will use this in doing W116. So let me pull up 116 for a moment, just so we're clear on what's going on. 116 is based on 115. If you don't like your version of 115, go into the drive there, follow the Unit 1 document link in Classroom from a desktop or laptop, not from your phone, it won't work. Go into that link, go to the worksheets, go to the solutions, and you can use my W115 solution. Now, the first 5 questions here are based on graph 1. What is graph 1? It's questions 1 and 2 from W115. So, if you pull up, let's get on over her. If you pull up W115, it's just a few tips about graphing. If you pull up 115, you'll see questions 1 and 2 are this graph. So when you're doing these questions here, 1, 2, 3, 4, 5, they are based on that graph. Then the next few questions, 6, 7, 8, and you see it's continued here, and 9 are based on graph 2, questions 3 and 4 from W115. So here's 3 and 4 from 115. And obviously this pattern continues. These 4 questions are based on the next graph. And finally, the last 3 questions are based on the 4th graph. Okay, so this homework, there's no additional homework. Just do this, take your time, 2-point format. Do this right this time. Spend the sweat on it, and you'll be sharp. You know, there's a little bit extra with the busy work over here, but it's going to make you good at it. And that's part of what we need. We need that accuracy, not only in thinking, but in organization and presentation. All right, then.